going to introduce Keras to you. What is Keras? Keras is a high-level library used specially for building neural network models. It is written in Python and it is compatible with both Python 2.7 and 3.5. Keras was specifically developed for fast execution of ideas. It has a simple and highly modular interface which makes it easier to create even complex neural network models. This library abstracts low-level libraries named Nano and TensorFlow so that the user is free from implementation details of these libraries. In fact, what I can say is, comparatively, when we compare it to TensorFlow, this is really simple, consistent, and extensible API. The code is minimal and it is extremely powerful. Keras is a user-friendly framework which runs on both CPU and GPU. It supports both convolution and recurrent networks. It has high scalability of computation. So what are the advantages of Keras? In comparison to Theno and TensorFlow, it takes in all the advantages of both of these libraries and tries to give a better user experience. As Keras is a Python library, it is more accessible to general public because of Python's inherent simplicity as a programming language. A similar library in comparison to Keras is Lasagne, but having used both, I can say that Keras is much easier to use. Now let us discuss about the limitations of Keras. I think that having a dependency on low-level libraries like Theno, TensorFlow is a double-edged sword because Keras cannot go out of the realms of these libraries. For example, both Theno and TensorFlow do not support GPUs other than NVIDIA currently, and hence Keras too doesn't have the corresponding support. That is the major disadvantage. And also, unlike Lasagne, Keras completely abstracts the low level languages. So it is less flexible when it comes to building custom operations. The last point I will make is that Keras is relatively new. The first version was released in early 2015 and it has undergone many changes since then. Although Keras is already used in production, but you should think twice before deploying Keras models for productions. So now let us understand how Keras helps. So now we write code in Keras and you will convert the code with the appropriate library and then it can be executed. For example, if you choose TensorFlow, then it will execute it in TensorFlow and return the results. This is really cool. Nice. So let us compare Keras, TensorFlow, and PyTorch. Keras is an open source neural network library written in Python. It is capable of running on top of TensorFlow. It is designed to enable fast experimentation with the deep neural networks. TensorFlow is an open source software library for data flow programming across a range of tasks. It is a symbolic math library that is used for machine learning applications like neural networks. PyTorch is an open source machine learning library for Python based on Torch. It is used for applications such as NLP, that is natural language processing, and was developed by Facebook's AI research group. So why do we compare Keras, TensorFlow, and PyTorch? Because there is always a debate between the people that whether we can use this or TensorFlow or PyTorch. So basically, these three are differentiated by certain points. So whenever you work with the deep neural network, always I advise you to go ahead with the Keras, right? So that's really great, but there are certain limitations. So when you when you work on that, you should also think about it, whether that is going to be, really affect your model or not. Okay? So hope this is clear to you. Thank you.
In this video, let us look into the practical implementation of Keras. So for this, I have chosen a data set, fashion MNIST, and I'm going to use Keras on that. So let me give you the introduction of this data set. This is a data set of 60,000 28 into 28 grayscale images of 10 fashion categories and along with the test set of 10,000 images. This data set can be used as a drop-in replacement for MNIST. So let me show you the labels now. Labels and description is given here. Label 0 corresponds to t-shirt or top, 1 is trouser, 2 is pullover, 3 is dress, 4 is coat, 5 is sandal, 6 is shirt, 7 is sneaker, 8 is bag, 9 is ankle boot. So what we are going to do over here is we are going to do image classification using Keras. Hope you are all excited. So let's see how we are going to write the codes, right? Okay, fine. So the first one, what is the first step? We have to import the necessary packages. So what are the packages required here? First, I'm importing NumPy and then matplotlib. So I hope you are all familiar with this matplotlib code. Import matplotlib.pyplot as plt percentage matplotlib inline, right? So let me execute the code now. Yay, it's executed. So now just I'm importing Keras. So it may take little time, and then keras.backend.backend. So it's returning me the output as TensorFlow, right? Okay, so this is fine. Now I have to import my data set, right? So the data set is available in Keras dataset. So I'm going to take from there. So from keras.datasets, import fashion underscore MNIST, right? So import fashion underscore MNIST. So just I'm loading my data over here. So here you can see x underscore train, y underscore train, x underscore test and y underscore test, right? So let me load the data set. Yes, it's done. Now just I want to know the shape of my x train data. So x underscore train dot shape 60,028, 28. So what does this mean? So already I told you that there are 60,000 images with 28 and 28 pixel, 28 cross 28 pixel, right? So let me check whether test data, it is 10,000, 28, 28. Again here, the number of images is 10,000 and the number of pixels is 28 into 28. Hope this part is clear to you, right? So now we know about the shape of training and testing data. So what are we going to do now? Let me look into one image. So what I'm doing now, x underscore train 0. So I want to look into the image now. Now, if you look into this, this looks like some numbers, which is not really appealing to me, which means that I'm not very happy in seeing these numbers. So what I could figure out is these numbers are ranging from 0 to maybe 255 or something. Maybe yes or no? Yes, right? So it's ranging from 0 to 255. Okay, fine. Now what I'm going to do, just I want to look at the image. So I'm writing the code plt.matshow x underscore train for 0th label, right? So now I can see a picture over here, right? So this is the output it is returning. So I really want to know what it is. So what I'm writing now with the Y train, I'm checking now and the output is 9 over here. So let me go back. What is this 9 actually? The 9 represents ankle boot. So now let's come back. Yes, it looks like ankle boot, right? It's clear, right? So let me also check one more image now. My God. Okay. So yes. So plt.match show, I'm checking for this 8th. So this looks like sandal for me. Let me check. Yes, it says that 5. So let us look over here. Yes, 5 corresponds to sandal, right? So hope till this it is clear to you. Similarly, one more we will check. And Y train says it is 2. So 2 means pullover, right? Okay. So this is how we can look into the images. Now what I'm going to do is I want to normalize the data, right? I have to normalize the data. So what I'm doing now, x underscore train is equal to x underscore train divided by 255. And similarly, x underscore test equal to x underscore test divided by 255. So all the images will be of the same scale, right? Fine. So let me execute this code now. And when I execute this, now you can see that all are ranging from 0 to 1, right? Yes. Fine. So that's clear now. Now this part is being done. Let's try to understand, because basically we are trying to build a neural network, right? So that's what our aim is. So what are we going to do now? So if you look here, I have used the code from Keras.models import sequential, right? Import sequential. And then what I have done from Keras.layers import dense, activation, and flatten. So let me tell you what this flatten does. This layer transforms a 2D array, which means matrix, into a 1D array of 784, that is 28 cross 28. So think of this layer as lining up the images from a square to one long line. So what it does is, it simply reshapes the data. Now dense. So this densely connected layer of 126 neurons. Neurons means nothing but node. It takes input from all 784 nodes in the previous layer, weighting that input according to hidden parameters, which will be learned during training, and output a single value to the next layer, right? And then we know about this activation function, like it could be ReLU or softmax. So I'm using ReLU and ReLU for the hidden layer and softmax in the output layer, right? Now I'm writing model equal to sequential. Now what I'm doing, first I'm going to flatten it. So 28 comma 28, that is the input shape. And then I'm writing dense and I'm writing it as 20 neurons, and activation is equal to ReLU. And this is for the output. The output I have to write it as 10 because there are only 10 outputs, right? 0 to 9. And activation I'm writing it as softmax, right? Fine. So let me get the summary of my model now. Yes. So in flatten you can see 784, and in dense I have given 20, and here the output layer I have given 10, right? So now I'm going to compile my model. So the loss what I have chosen is sparse categorical cross entropy, and optimizer I have chosen is just Adam, and metrics I'm choosing accuracy, right? Now the model is compiled. I'm going to fit it with my training data, X train and Y train. And this is the accuracy I'm getting, and this is the loss. Okay, in case if I want to add epochs to that, I can give like 5 epochs, right? So this is what I'm getting, right? Fine. So epoch 1, 2, 3, 4, 5. So totally 5 epochs I got. So you can see the loss and accuracy over here, right? So what I'm going to do now, I'm going to predict now. So y underscore predict I have taken, and this is equal to model dot predict x underscore test. Okay. So now I want to look it as a picture. So just I'm giving it. Do you remember what it is? Let us see. Okay, so this is showing an image y underscore predict of 1. So when I print out this, this is showing some probabilities. Why it is showing probabilities? Because in the output layer, I have given softmax, right? So that it is showing some probabilities, right? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 probabilities I'm getting. So in case I want to know which is the highest one among this, so it is saying that it is 2, 0, 1, 2. So which means that this has the maximum probability. This has the maximum probability. So let us see what is this 2, and let us try to see whether our model has predicted it rightly or not. Yes, it is pullover, right? Yes, we are right. Already, right? So already we have seen this, right? So now what it is predicting it perfectly. So I think we are on the right track. So if it is needed, we can also check with something else like 7. Okay. So let me find out now 7. So here also I'm changing it to 7 now. Right. So now it is saying sixth, right? 1, 2, 3, 4, 5, 6. So this has the maximum probability. So let's see what it is actually. Sixth one means shirt. Yeah, it is very obvious that it is a shirt, right? In case if you want to give it as 217, is this different? Something different? Have we seen this before? Yes. Sorry. So this should be single 7. Yes, so it's saying 6. Let's see what is 6 here. 6 is a shirt, right? So again, it is a shirt, right? So you can check for several labels and see whether no, it is working perfectly or not. And in case if it is required, I can also change the number of neurons. And before that, let me evaluate my model. And this is giving 85% accuracy, right? So this is giving 85% accuracy with my testing data. So what I'm going to do now, okay, so what I'm going to do now, I'm trying to change with the number of neurons and see. Yes, the performance has increased, right? So now it is changed to 86. So like this, you can play with the several values because there are no golden rules to find out the right number of neurons. So you can change that. You can change the number of neurons and then see, then try to find out the performance of the model. If you are really getting more than this, then it's really great. Hope you understood this practical implementation using Python and Keras. Thank you. So if you have any questions or so the most important thing what I request is take a data set, work on that so that you will get a sound knowledge on Keras. Now we are very much familiar with the machine learning algorithms. Now let's see what exactly we need to build this machine learning models. Right. So first look at the things that we need one by one. First of all, we need lots of data, right? I mean, if we have to do machine learning algorithms, then definitely we need lots of data, which means I need a good amount of data, right? So that's the first thing. The second thing is that we should have a hardware. Now, why are we talking about hardware? I mean, every program, software program that we write needs to run on a computer. So it needs a hardware. So we are talking about the hardware here. And also, it's because in machine learning and deep learning, we require specialized hardware like GPU because we are going to do lots of matrix multiplications and additions. And apparently, these machines' GPU is really required, right? So that is the most important requirement of the hardware. Hope that is clear. And these GPUs are really required to do matrix multiplications and additions. So we need GPU as you go deeper and deeper into this field. Now the third thing we need is software, and we understand that every program will require some software library. So for machine learning, the reason we need to implement all the mathematics. So as we understand, machine learning is nothing but mathematics. So we need software which actually implements that mathematics so that we don't need to write the code every single time. So how does sigmoid work? We know how ReLU works or Adam works. Those things we need not worry about. Rather, we can just call those specific APIs and it does the trick, right? So these are the primary reason why we need, we know, like a specialized software, right? Now let's move forward. Let's assume we have data, right? We have data because otherwise we will not be learning these things, right? So that is clear, right? Otherwise we will. So the data is the most important thing actually, right? So the next thing what we require is the software. So the software what we are going to talk about here is the TensorFlow. It was found by Google in December 2015. So there has been a lot of work done by the TensorFlow, and it is most popular deep learning library. Now there are other few, definitely there are more options. Now TensorFlow, one thing about is it can be supported across Linux or Ubuntu. It can be supported by Mac. It can also be supported by Windows, right? So it can be, TensorFlow can be supported by uh, all the platforms, okay? And also it can be supported with the languages like Python, C++, Java, and R. So we can also use R with the TensorFlow. So for our course, we are going to use Python because that is the thing we have selected, right? So Python will be the choice of language for this course. Now, how do we install TensorFlow, right? So that is really required because if we have to do that, if we have to use the TensorFlow, so first we have to install it, right? So let me tell you how to install it, right? TensorFlow.org/install. So you can go to this URL. You can just go to this URL and install this library. Okay. So that is the easiest way to do it. Now, when we want to use the TensorFlow, we should have a Jupyter notebook, and also we have Pandas. I think, I hope you all have Pandas library and also the scikit-learn, right? Now, TensorFlow is an open source end-to-end machine learning framework for all developers. It is used for implementing machine learning and deep learning applications. To develop and research on fascinating ideas on artificial intelligence, Google team created TensorFlow. So TensorFlow is designed in Python programming language, hence it is considered an easy to understand framework. So these include data pre-processing, data ingestion, model evaluation, visualization, and serving. We can easily train and deploy our model. TensorFlow approaches series of computations as a flow of data through a graph, with nodes being computation units and edges being flow of tensors. So basically these are multi-dimensional arrays. TensorFlow builds the computation graph before it starts execution. So the computations are scheduled only when it is absolutely necessary. That's the reason it is called as lazy programming. The graph is not actually executed when the nodes are defined. After the graph is assembled, it is deployed and executed in a session, which is a runtime environment that binds the hardware it is going to run in. So it is a small introduction about the TensorFlow. Hope you all understood the concept.